I'm Tom Seidner, and welcome to this video, Anatomy of an If Statement. So when we're programming, the one thing that can make our programs a lot more powerful is the ability for our programs to make decisions. And when our program makes decisions, it always makes decisions based on some parameters, and the outcome of those parameters are always true or false. Now, the parameters can be an actual true or false event, something like a Boolean variable, where we could set up a Boolean variable called print to screen, and if that variable is true, then we do what the decision says, and if it's false, we do not do what the decision says. In an example, if we had a print to screen variable and we set that to true, and we had a piece of code that says if print to screen do this code, then it would do that code. Now, if print to screen was false, it would skip that code altogether. That's called a simple if statement. So in this example, the car is coming along the racetrack, and at this point, it has to make a decision. The decision can be based on its tires. So we could say that if the tires are less than 50%, then the car is going to go into the pit stop. If that happens, this piece of code is executed. We go ahead and execute this code, and when we're done executing this code, we leave the pit stop and we continue on with our code just like we normally would. But let's say that condition is not true. Let's say it's not true that the tires are less than 50%. If that's the case, then we skip this code altogether and we continue on through our code as if this code right here never existed. Here's an example of that in some different languages.
So here's an example of a simple if statement in C++. As you can see, we went ahead and we declared a Boolean called print to screen. In C++, we denote the Boolean as bool, and we say equals to true. That means that this condition is now true. Our program has some code above the if, so this is going to print out before the if, and our code has some printout after the if, so this is going to print out after the if. And then we've got a printout inside of our if. Now, the way this works is our program is going to start at the top and it's going to move to the bottom, and it's only going to do this snippet of code if this condition is true. And it is true because we set it to true. So if we run this right now, it should print this, and then this, and then this. So let's give it a try. So first it printed this is the code before the if, then it printed this was printed to the screen, and then it printed this is the code after the if. Now if we see if we want to have that stuff be on its own line, then we have to concatenate in and endl at the end of each one of these. And now when we run it, you can see it prints them on their own line and then does a return at the end of each one. Now it says this is the code before the if, this was printed to the screen, which is what was in the if, and this is the code after the if. Now, if we set this to false, then this is never going to execute the code within the if because this is not true anymore. And this only happens if this is true. So now when we run the code, it says this is the code before the if, and this is the code after the if. And the code that's inside the if is missing, and that is working correctly. Here's an example of the same code using Java. Java is pretty similar to C. It does create its Boolean with the word Boolean instead of bool, like C does, but we can still set it to true. We have our system.out.println to print this is the code before the if, as well as this is the code after the if. And then inside our if, this was printed to the screen, is going to print if our if statement is true, and it currently is true because our Boolean is set to true. So we're going to go ahead and run that. And as you can see, it says this is the code before the if, this was printed to the screen, and this is the code after the if. Now, just like the C++, if we set this to false, and we run this, this if statement will no longer produce output because this is no longer true. And now it says this is the code before the if, and this is the code after the if. Now let's look at Python. Python is quite a bit different, so you have to know the rules for Python. The first thing, to create a Boolean variable, we just put a Boolean value in it, and Boolean values can only be true or false. So putting true into print a screen automatically makes it a Boolean value. We do not have to tell it what type it is. Then we have a print statement to print, this is the code before the if. We have a print statement that says this is the code after the if. And then we have a print statement inside the if that says this was printed to the screen, just like the others. The one thing you have to note with Python, unlike C and Java, C and Java both have a begin bracket and an end bracket for their if statements. See that in both of these places, begin and end. Python does not use begin and ends, so it uses indentation. And so in order for us to do something in an if statement, first we have to end the if statement with a colon, and then everything under it that is indented will happen if the if statement is true. So we can put multiple lines of code under here. All of them will have to be indented to the right in order to execute when this statement is true. Let's go ahead and run this Python. And you see that we get, this is the code before the if, this was printed to the screen, this is the code after the if. If I change this to false, and the false does have to be capital in Python, and then I hit run, you can see that now it only printed this is the code before the if, and this is the code after the if, just like our other programs. So all of these if statements work in a similar way. They just have a little bit of difference to the syntax in order to make them work.
Now, we can also base the decision on mathematical parameters, and we can also do complex decisions. So when I say we can do that based on math, we could do something like if 1 equals 1. Now everybody knows that 1 equals 1 is always going to be true because 1 is always going to equal 1. So in that case, we would always do the code that is in the if statement. But we could do things that are not always true, because we could say if the value of x is less than 5, do whatever's in this decision. Well, if x is equal to 1, then we're going to do what's in the decision. And if x is greater than 5, then we are not going to do what's in the decision, and we're going to go ahead and pass it right by. We can also do even more complex decisions by using and or. In that case, we can have two options, and if we say and, both of those two options have to be true in order for the entire decision to be true. If we use or, then only one of those options that we give it have got to be true, and in that case, the entire decision is true. And or can be used in combination with each other and can be used for multiple different decisions. So I could have this, and this, and this, or this. And depending on the order of operation is going to depend on whether or not those decisions are true or false. My suggestion is to come up with some complex decisions for yourself and see how they work. Do some of them straight, do some of them with parentheses around different parts of them, and see how the order of operation affects the decision. Here are some examples of complex decisions using mathematical equations in different programming languages.
I'm going to go back to this C program to show you how we can use something other than a Boolean for our decision. I'm going to make this Boolean a remark. That way, if I want to use it again later, I can bring it back. A remark just says that this code is still here, but it doesn't actually function in the program. So let's make an integer variable. and make it equal to 1. Now we can do a mathematical condition in our if statement, and we can say if my int is equal to 1, then go ahead and perform this action. In this case, my int is equal to 1, and so this is going to happen. One thing to note, that in an if statement, we can't just put equals in here because that's an assignment statement. So we have to do equals equals, and that way it will compare. So equals is an assignment statement, as in my int is equal to 1, and equals equals is a comparison statement, as in is this equal to that. So let's go ahead and run it. And you can see that it is equal, so it went ahead and printed. This was printed to the screen. Now, if I said, is it equal to 2, this would no longer be true, and now when I run it, this code is no longer printed. I could also do something like, if my int is less than 2, in this case, it is true. 1 is less than 2, so when I run it, it does print because this is currently true. If I made this false by saying this was 5, and then I run it, it's no longer true, and this code does not get executed. The last thing is we can do complex decisions within our if statement. We can say if my int is less than 2, or, and double pipes is the or for C++, my int is greater than 4. Then in this case, it will evaluate both of these, and if one of these items are true, then it's going to go ahead and do what's in here. So this is not less than 2, but it is greater than 4. So when we run this, this will get executed. Now, if we change this to AND, the double AND symbols are how we do AND in C++, then this is now going to evaluate whether or not both of these are true, and the only way this whole thing is going to be true is if both of these are true. So it's going to say, is my int less than 2? No. Is my int greater than 4? Yes. But one of these is not true, so therefore the whole thing is not true. And so when I run this, you can see that this line is not going to get executed. You can do complex decisions in all of the languages, but you may have to do a little research to determine what the operand for AND and OR is in the different languages.
The other option that we have for decisions is an if-else decision. That's a decision where if the decision is true, then we do one thing, and if the decision is false, then we do another. In that case, you have to do one or the other of the decisions. We use the same types of decisions or parameters to decide whether the if statement is true or false, but then we always do the else if we don't do the if. Let's also say that somebody built a McDonald's on this side of the track. Now our driver could be in an if-else situation. He could come here and say, if the tires are less than 50%, then we go into the pit. Else, if the condition is not true, that the tires are less than 50%, then we go to McDonald's. Once the condition that we choose, either the if condition, tires are less than 50%, or else condition, go to McDonald's. Then, once that's completed, then we continue on with our code as we normally would. Now keep in mind that in an if-then-else situation, we cannot go to the pit and then somehow turn around and go to McDonald's. Okay, that is not allowed. We have to make a decision based on the condition and whether the condition is true or not. So if the condition is true, we do this, and if the condition is false, we do this. Here are some examples in different languages of the if-else statement.
So in this example, we're going to do a more complex if statement called an if-else statement. Now, in an if statement, it's pretty much set up that if it's true, it does the code that's in the if statement, and if it's false, it doesn't do anything, and it just goes on with your code. Well, in an if-else statement, you give the code two options. If it's true, you do the first option, or the if option, and if it's false, you do the second option, or the else option. Either way, when your code runs, one of these options is going to be executed, and there's no way to not have one of them executed. So when you run your code, either this one or this one is going to be executed. So in this case, we are still on false because we've got this and here. And so if we run it, it's going to execute only the line that says this was printed on false. Let's go ahead and run it. And you can see this line was printed on false. If I make this true by changing this to an or, and I run this C+ program, and you can see this was printed on true. Now, so if you want your program to have two options, and one of those options is definitely going to happen, then you want to use the if-else statement. Now in C++, the if-else statement, you just add the else after the end bracket of the if, and then you give the else its own beginning and end bracket, and then anything that happens in here will happen if the thing up here does not happen, or if, in essence, if the if is false. Putting this else right next to this bracket tells the compiler that this else goes with this if. So if you have an else, it has to go with an if. You can't put an else in there by itself. The syntax for Java is pretty much identical to the syntax for C++. Your else goes next to the end bracket of the if. It tells it that this else goes with this if, and then it has its own begin and end brackets that contain the code that will get executed if the else statement is run, or if the if statement is false. Python is a little different. You put the else at the end of all the indented lines for the if. So if you had 5 indented lines here, then the else would go after it. The else is preceded by a colon, and then you have another set of indented lines after the else, which is everything that you want to happen if the else statement is executed. And that's it. That's how you do an if-else statement in these 3 languages.
One thing to keep in mind, that decision statements don't really branch your program. Some people think that decision statements actually send you in a Y branch, and it really does not. The thing to keep in mind is that a decision statement gives you a partial piece of code that can be executed or may not be executed, but your program still follows a linear path once it's done executing or not executing the decision. As you can see, I've got this car here. Normally my program runs from the start of the program or the start of the method all the way to the end of the method. In the event of decisions, my program may run, it may do some offshoot, and then run again where it would have normally left off. So decisions don't change the direction of your program, they just give you options in your program that may or may not be executed. Well, I hope this helps when using decisions in your programs, and as always, if you have any questions at all, please feel free to email me. Decisions are one of the important underlying constructs for programming, and they are available in all languages, so it's very important to understand these concepts. I hope you enjoy using if statements in your code, and as always, until I see you again, happy programming.